Today on What's Inside, we're going to be looking at a hairdryer. This guy's been serving a reasonably long lifetime. And sounds like shot bearings on the fan. And if I go fire them up, which I happen to have power here to do so with. Don't know if he's going to do it. Yeah, you hear that? Bad bearings. The two screws here at the bottom have been taken out, so now this piece just kind of pries off. And now, on the back, we can see we have a grill here which catches all the crap in the air. And then this whole assembly pops out. With this, we'll pop this guy open in a little bit, and then the switch module here should just pry off, yeah, and we can see this guy's completely gunked up. I'll try to pop him open, see how nasty. Oh, and it feels fine once you remove a lot of this gunk here. So it's mainly the gunk that's this issue here. As in, let's look at this. So you got a filter here. This actually pops right open easily. So here is the actual insides. Heater coils, we have two different heater coils, it looks like here. Actually one from when I turned it on. Oh, that's soldered into the motor, so that'll be fun to remove. These are actually normally DC motors, because if you look carefully right here, what you could see is there's enough diodes right on the top of this motor to make it a DC motor. These are often like 10 volt DC motors. We'll play with that in a little bit. Heater coils, we'll find out the actual resistance of these. It looks like they have two resistances. We probably also have a thermal shutoff probe here we could play with too. And then just a filter here for the motor. We'll find out how bad that is. Oh, you could see actually, those blades look cracked. Two, boring cord. And then let's go pry this guy open. And you can tell they don't want us in there because they have triangle bits. But luckily I also have the triangle bits. I have the triangle bits to open these. And this is essentially a little GFCI attached here. It's designed to be used in a bathroom. And GFCI, you don't actually need a grounding pin. This guy doesn't have one, if you can tell. And what it essentially does is you have a current meter on those two pins. We'll find out pretty quickly because it's going to be opened. You essentially have a current meter on both of those pins. And then you have, and then what happens is if the power is going through the heating coil into the blow dryer like it normally should, the current will be approximately the same, or it should be exactly the same. If the current is going through you or something else to the ground, or another thing, something else in the house, then it will shut the power off because more power will be pulled out of it than put back in, essentially. That's the simplistic way to think of how these GFCIs work. And we're going to see inside one right now. It's just not that hard. Okay, so you got the reset buttons here. This is, oh, they probably soldered this in. Oh, this isn't coming out easy. We'll just break it off. Okay, so inside here, it's pretty much exactly what you see. It does seem to be doing it a slightly different way. So you have a wraparound coil here. With both of them, and what it probably does is it says it'll produce a voltage in one way positive if more of the power in like the red one is higher. And it should normally be none because these two should cancel themselves out. And if it doesn't cancel itself out, you can see we have a little kill switch here which will kill, it actually has two switches. It will kill both ends of it. It's a pretty simplistic little device. Can I pop this guy open anymore? Not easily. You can see there's very little components in there. Basically just says if this voltage isn't nothing, it'll switch it off. Simplistic device. And if I was to, here, I can do a pretty darn quick demo of this in a little bit. So here's that little GFCI demonstration. Here's a GFCI connected to the power outlet, which is connected to this fan. It's basically the same thing that we'd have in the other system. We turn it on, fan spins up just fine, no issues. Now we're going to have a little bit more fun. So here's another pigtail. Essentially all we're going to do is we're going to only pull power off of one of the leads in this guy, essentially saying, what if we took the hot lead in here and essentially grounded it? Or the power is going through a body instead of through the other end. So that's the demonstration we're going to try to show here. So essentially the circuit is the hot line in here, the small pin, goes through this guy, goes to the fan, and then goes to this guy, which goes out to here. This should trip the GFCI. And yeah, you just heard it. it snapped. So if I go hit the reset button, you can see how this button goes up. How this button goes up, I tap it again, you hear it, you snap it every time. Fan only moves a little bit. And here the motor is plugged into a little test bench sitting on my vise. It's currently shoving 5 volts to it at about a quarter of an amp. And I can shove it all the way up to 20 volts, and then you hear it, something's touching. This actually needs to be tightened a bit more. Yeah, and it's doing this even if it's not on the vise. Right now, 20 volts, about 1.5 amps, so thinking probably around 35-ish watts. Motor doesn't really feel warm, but definitely is being cool. It is moving quite a bit of air at a pretty reasonable pressure, but it's obnoxiously loud. And we can see it is scraping here, so let's go take the top off and find out what actually is scraping in there. Okay, so here's essentially what your problem is. I don't know how well you can tell this on camera, but you can see how beat up these little blades are right here. So you can see that the front end tip is very cut up, probably by hitting just stuff in the air, and this right here looks like it wasn't supposed to be happening, but it's starting to crack right in here, and probably under those RPMs, it's touching this outside and scraping it along. Motor bearings seem fine, it's just scraping it, and it sounds horrible. Motor runs fine, it's just, yeah, scraping. So this is my horribly drawn, really simple schematic, and essentially what you do is this little switch here is what controls it all. So this little, oh, I think I colored it right. This purple lead is what does the fan, and it goes to a really small coil just to drop the voltage down, because it's probably a 12-volt motor. Bridge rectifier, because it's a DC motor, for whatever, I don't know, DC motors are probably just cheaper. And then they have a thermal protection on everything. And then you have a big coil and a medium coil, and essentially, depending on which ones you fire, changes how much heat you have going into it.